Good. Okay. All right. So this is very much a draft of how I think the IOF mid-level ontology, the general ontology, should look if it's based on BFO. I'm constrained by the fact that I have to include the 20 terms, which turned out to be somewhat more than 20 terms, some of which I believe are not appropriate. They're just too vague. But I tried to provide treatment for all of the 20 terms. I'm also constrained by the fact that I believe that the strategy here should not be to have a single mid-level IOF ontology. Rather, there should be sub-ontologies for things like commercial aspects of a manufacturing enterprise, or sales, or marketing, or regulation conformance, and so forth. And so some of the terms in this big ontology collection will belong in the future, I hope, to smaller modules. So this looks like one big module where, in fact, I think the appropriate way to proceed is to have a number of smaller modules, all of which should then be descending from BFO plus the various portions of other ontologies, which I will identify. Again, always only in the very early draft stage. So the general vision we've already seen at various points. It has to do with a distinction between material things, information things, and processes. And that's also the basics organization of BFO. And if we put those three kinds of entities and arrange them along a time axis, then we get the product life cycle. And the product life cycle is a planned process. So when a manufacturing company organizes its procedures, its operations, and so on, it creates plans, and then it tries to realize those plans. And when it succeeds in realizing those plans, which it mostly does, then we get the planned process, which is the entire product life cycle, ending in things like selling products and using products and maintaining products and disposing of products and so forth. Now, of course, sometimes it fails for one reason or another. But the BFO strategy is always to start with the canonical case, the case where everything goes as planned, and then to deal with the deviations from that canonical case in extra ontological content. And the reason for that is that if we try to deal with all the deviations from the canonical case at the beginning, then we will create an infinitely large ontology, which will never be useful. So this is an ontology primarily of planned processes. So we have design process and so on. And then some of these processes have outputs, such as a production plan or a product, which is an output of a production process which is guided by a production plan. So these are the three kinds of entities: processes, information entities, and material entities. And we have different kinds of plans for different kinds of processes. We have raw material, which is an input to the product, and so on. And this is the overview. So products, people, factories at the bottom, information entities in the middle, and then processes at the top. All right, now this is the hierarchy for the 20 plus terms, which has been formalized in an OWL file, which you should all have received a link to. And these are the 20 terms. It turns out that there are 23 of them by our count. This is the independent continuant part of all of that. So products are independent continuants. Material resources are independent continuants. Completed assemblies are independent continuants, and so on. Then we have specifically dependent continuants, which include things like qualities, intentions, capabilities, functions, and then most importantly for our purposes, roles, because most of the planned processes that we deal with involve agents, for instance, and materials, and so forth, which are entities which play certain roles. So nothing is an employee. Rather, there are people who have an employee role. And in order to define employee, we need person with employee role. That's the BFO strategy. And then we have occurrents such as action, steps, tasks, transport, processes, and so on. And we have generically dependent continuants. This is the BFO stepping stone to defining information entities and other abstract entities, such as models and so forth. And I'm going to talk quite a bit about information entities because they are what makes a planned process a planned process. And so now the BFO does not contain any abstract entities except the one term generically dependent continuant. From this term, all other abstract entities such as software and so forth descend. And we have collected many of those terms in the information artifact ontology. And part of our job in building the IOF formalization was to extract some content from the information artifact ontology and also some content from the Common Core ontologies, where specific applications of the basic BFO approach to generically dependent continuants have been developed for other industrial projects. And so important here is specification. So the way we deal with things like plans, objectives, and so forth is always through specifications. There are no plans without plan specifications. Now, sometimes those specifications are written down. Sometimes they are programmed into a computer. Sometimes they are taught to personnel on the shop floor. And then usually there is something written which precedes the teaching, but now the plan specification is what the people on the shop floor hear by way of instructions. Now, these are terms inherited from the information artifact ontology, or rather, these are terms which are inherited from or descend from terms inherited from the information artifact ontology. And we'll meet most of these terms again as we go along. Now, there are two main kinds of entity within the information artifact world. There are descriptive entities which describe, and what that means is that they are created in such a way as to capture what the world is like. So we talk about a document to world direction of fit, or data to world direction of fit. We're trying to capture what the world is like. And of course, we have many such documents and data resources in a given manufacturing enterprise. But then, more importantly, are directive information content entities. These are information entities which tell people or things what to do. And most of them are grouped under the heading of specification. So the way we deal with plans, actions, and objectives is by looking at specifications of those things. Now, specifications prescribe reality. They don't describe reality. They have a world to document direction of fit. The world must become as specified in the document. So the document serves as a rule or a guide for processes, or it specifies a model, a paradigm which continuants have to satisfy. For instance, software or material products such as lathes or ships. Now, some of this content is formalized already in the Common Core ontology. The Common Core ontology will be one input to the IOF formalization that will be proposed and which has been proposed in a draft form in the document that was sent around. There will be other inputs too, but for our purposes, we need to make sure that anything we input coheres with the other things that we input and also with the needs of the IOF. So we couldn't import the Common Core ontology as a whole. Things have to be imported with great care in order to preserve consistency. All right, now IOF will need many terms relating to information entities and to abstract entities. Some of these we already have from IAO. Terms such as software and algorithms, some of them will we need to define anew. And we have done very little work in defining mathematical entities in IAO, but there are some mathematical entities in IAO, including things like measurement results and units of measure and equations, for instance. And we're working at the moment on extending those kinds of entities in the BFO framework for other purposes. The reason why we don't have a BFO-based ontology of mathematics is because the ontology of mathematics would take 1,000 years and it still wouldn't be any good. Mathematics is too complicated. But for purposes of engineering, we believe we can do a decent job. All right, now another important import is the ontology for biomedical investigations, which is a well architected ontology with very similar goals to the goals of IOF. These goals are, how do we do experiments? And many of those experiments have material inputs and material outputs, or material inputs and data outputs. And so a central term in OB is has specified input. And the dual of that then is has specified output. And so this is being used by hundreds of people to describe experimental protocols. And it's an OWL ontology. So the OWL of OB is extremely mature. And we have already imported some of it for the ontology of functionally graded materials that we created a couple of years back. And we will be importing certain other elements of OB as we go along. This is the architecture of OB at the very high level, and this will be very similar to the architecture of IOF if the architecture of IOF is based on BFO. So you can recognize many of the things here that we've already talked about, including planned processes. Okay. Now, I've said various things about the strategy for this formalization. I'll give you something by way of a progress report. So we have OWL and first order logic formalizations which have been distributed, and they are very early drafts. As I will keep repeating, this is very difficult work. Now, the first order logic version will exist also in other formats. So Alan Ruttenberg has created a set of tools which enables us to generate automatically different formats, including the Prover 9 format and formats for other Prover environments, so that we can test for consistency of this work as we go along. So we won't just be throwing out axioms into the ether. We will be developing a system and checking it for consistency as we go along. Now, as is already clear, this work is going to incorporate, and already does to some degree, incorporate elements from other ontologies. Now, we know IAO and CCO and OB very well. We do not know PSL so well, but it's clear from what we've seen already that if this is going to be a mature representation of the operations of a manufacturing enterprise, then we're going to need to incorporate some elements taken over from PSL. Again, the importing process has to be done very carefully in order to maintain consistency, not only logical consistency, but also terminological consistency. I anticipate that we will also import some elements from Dolce. So I have said for some time that Dolce's treatment of quality spaces is a contribution which BFO is going to need to incorporate. BFO incorporates things very, very slowly in order to ensure that they are truly going to be compatible with the already existing content of BFO, but also with the 300 or so projects which are using BFO, some of which are very mature and have very complicated needs and immediately get concerned if BFO changes. And then we're also already drawing on work by Farhad and Tom Hagedorn and by others who are already building engineering ontology using BFO. And you can find some examples, published papers on that work at the link here. All right, so now we'll go through various parts of the document, the first order logic document. I include some formalizations, but for these purposes, I'm focusing on the English language specifications that we will be using as the basis for the formalization. Formalizations are sometimes in the form of definitions, sometimes just in the form of axioms. You should be able to see which is which by looking at the symbolism used in the formalization. And the goal is that we have as many definitions as possible, but we will have some terms which are primitive. And what that means is that we can't give definitions, we can only give necessary conditions, we can't give a complete set of sufficient conditions. All right, so a specification, that's a directive information content entity, which comes from IAO. And what a specification prescribes can be anything, really. So the directive information content entity has been used a lot in various ontologies developed for the intelligence community. And directive information content entities include things like recipes, instructions, musical scores is another example. But the big example would be commands issued by a military organization. Specifications specify, and what that means is that they prescribe some feature or outcome or part of a planned process. So this is, I believe, what the word specification as used in the manufacturing environment means. That you're not specifying something simply in order to have a description either of an actual case or of some future case, but rather you're specifying something in light of how you might make it or bring it into existence or make it happen. It means that you're prescribing some aspect of a planned process. And now we have action specifications which directly prescribe a process. We have objective specifications which prescribe the end point of a planned process, and so on. And that's what the rest of the slide says. All right, now plans exist first of all as plan specifications, but not every plan specification specifies a plan. And what this means is that there are many plan specifications which are created, which are never ever transformed into intentions on the part of agents to realize that plan. So companies build many plan specifications and then they throw away 90% of those plan specifications because they are not deemed to be realizable. So many plan specifications exist after the plan has been realized. The specification survives the plan because it was written down. What we get out of a plan specification when a plan begins to exist is an intention. This might be an intention on the part of a single person, or it might be an intention which cascades through multiple persons and teams and so forth as part of a larger organization. So plans can be intended by agents in general. And once they are intended, then actions start to take place. The plans have to be in the heads of the people in charge and the people who are executing. But they are written down, and when people talk about plans, it's much easier to talk about the written specifications than it is to talk about those distributed intentions in the heads of the people who are realizing those specifications. If we're doing ontology, we have to get those things clear. The same thing applies to objectives. So objectives we know primarily through objective specification. All right, so a planned process is a kind of process that occurs as the result of one or more intentions to realize the plan and where the process successfully does realize it. So this is a definition here. A manufacturing process is a planned process during which some material entities which are part of a product are modified. So a manufacturing process does not necessarily have a product as an output, but products which are nascent, which are coming into existence, are involved. Here we have not a definition, but an axiom. Every manufacturing process is part of a product production process. And remember, we're dealing here with planned processes. So if the factory catches fire and the company goes out of existence, then that would be a different kind of case. There will then be many manufacturing processes that were never parts of product production processes. But the fire process was not planned. All right, now business process is an example of a fork, and I am not qualified to decide which route we take. Some people use, it seems, the term business process to mean any manufacturing enterprise process, including maintenance processes, supply chain processes, and so on. Some people use business processes to mean just the commercial aspects of a manufacturing enterprise. I'm assuming that we mean the more general sense of business process, in which case business process is just a synonym of what I call a manufacturing enterprise process. Manufacturing enterprise process is included in the long document, which was the link to which was sent around. What we need to define manufacturing enterprise process is the list of all the things, all the processes that manufacturing enterprises perform, including maintenance, supply chain, and so on. And then also business processes in the narrow sense, where we mean commercially relevant process. So a business process is a planned process which is such that that process realizes the function of an organization, the business in question. That's the general sense of business process. And function is a BFO term. This fits exactly the BFO sense of function. All right. Now, as I say, I think that there will be modules in the ontology as it exists in the future, one of which will deal with things like customers. Yes. Yeah. That will come later, I hope. If not, it's in the document. Okay, so I must apologize that the order is not always the order that one would like. So I should have defined product production process earlier than I defined manufacturing process. That's because the 20 terms is not the ideal strategy for building this kind of artifact. Okay. Smaller number. Customers are a kind of agent, and being a customer, of course, is a role. Now, we had some difficulty here too with defining, because we believe we need a module for this rather than build it as part of a larger manufacturing-focused ontology framework. So when is a customer a customer? When does an agent bear a customer role? This is not an easy answer to a question to answer, but the proposal we're suggesting is that once you've made a decision to purchase and started the act of purchasing, then you are a customer. Well, and we have a prospective customer role, which is the person who's just window shopping. This was requested by, in one of the discussions of the 20-term list. And then a purchaser is a customer who has succeeded in coming to the end of an active purchase. Now, I don't believe that this is a very mature account of what customer is. I think it's a hard term which needs a lot of work to get right. And purchaser and supplier and other terms are hard terms. It's important to get right. I don't know of anybody who has produced a good ontology of these things yet, but we have people working with us who are going to be involved in helping to create this module. So a product is a kind of continuant which this is a role case again. So stuff which has been thrown on the trash at the end of its useful life is no longer a product. Products are products only for part of their life cycle. And what they are to be a product, to have the product role, in other words, is to be an entity that is the specified output of a product production process. Now, we're dealing with two kinds of products in the IOF. We're dealing with manufactured products, which are material artifacts, where an artifact is an entity deliberately created to have a function. But there are also informational products, such as software. And in these slides, I'm focusing on the material products, the manufactured products, but there is parallel work going on to create an ontology of informational products. And you can see why the commercial module is important as a module, because that commercial module will apply equally both to manufactured products and to informational products. Material resource, I think that's the wrong way around. Oh no, this is right. So this just restates what I was saying earlier. Just as there are two kinds of products, so there are two kinds of resources. One kind of resource is a material resource, which might be a building or a piece of equipment or a person. And then the other kind of resource is an immaterial resource, which might be intellectual property or licenses, or money. So that's just an axiom governing material resources. Material resources are manufacturing resources which are made of matter. This is just another role case. So here we're using has specified input. So if you have a plan, you can specify the input. There are no input materials unless there is a plan which involves specifying certain things as input materials, what this says. And similarly with raw material, it's exactly the same design. Here the raw material is such that it's not the output of any manufacturing process. And now we come to manufacturing process. So for that, we need process plans, which are kinds of plans. And in order to have a plan, we need a plan specification. So a manufacturing process plan specification is a plan specification that prescribes a manufacturing process. And now one example of a manufacturing process is an assembly process, which is a planned process of joining two or more objects together. Again, I'm not qualified to assess the adequacy of this statement. It seems to me to be true, given the specific sense of object in BFO. But whether this is an appropriate definition of an assembly process, this has to be decided by collaboration. The purpose here, remember, is just to show that BFO could be used to define these 20 terms. So an assembly process is a planned process which has a specification of an endpoint. That endpoint is a completed assembly. So the completed assembly is the specified output. Now, a work piece is an assembly which is not done yet. So a workpiece, it can be defined as an assembly that is not a completed assembly. There is an issue about how we define the relationship between a specification and the entity which is specified. And for that, we need to quantify not just over instances, but also over types, which the common logic formalization of BFO now allows. But that possibility is really just a few months old, and we've been testing it in other areas. We didn't want to go through the process of testing it here, but that will be the next step. And I can send you the content which we created to define the relationship between a specification and the entity specified, which involves quantifying over types. So basically, specification includes the representation of a type, and then the specified entity conforms to the specification if the specified entity is an instance of that type. And the type might be, in the case of specified input, it might be the input has to be a piece of raw material, which means it has to have the raw material role and so on. So component, every component is made for a purpose, so it's a material artifact, and it bears a component role. And what that means is that it's designed to be a proper continuant part, which means not identical to, but smaller than some material artifact. So we have two material artifacts going along here. The one which is the component, and the other which is the larger entity which the component is a component of. And then we can define the component of relation in the obvious way. A manufacturing machine is a kind of machine which we define according to the ISO definition here, which another question which we have not addressed here is the role of physics in the IOF ontology suite. I assume that just as there will be a commercial module, so also there will be a physics module, there will be a mathematics module. We haven't addressed either the physics module or the mathematics module here, but except in this definition, we do have a definition of engineered system, and function is already a BFO term. And now we can define a manufacturing machine as a machine whose function is realized in the manufacturing process. Now, function and realized and process are all BFO terms. Every machine has a function because every machine is a material artifact, which is what the definition says at the top. A supplier is a kind of agent, and to be a supplier obviously is a role, since nothing is a supplier, and in and of itself, you become a supplier at a certain point in time, and then you cease to be a supplier at a certain point in time. To have the supplier role is to be an agent who is capable of realizing acts of selling, and your supplier role is realized in such acts of selling. And then a supplier is an agent who bears this supplier role. And provider was one of the 20 terms, but we're assuming that provider and supplier are synonyms. But again, that is not for me to decide. That is to be decided in collaboration with the users of this ontology. Now, I've received several comments from people who are commenting on early versions of this material that the term tool is not sufficiently clear in meaning to be useful. But again, for the purposes of this exercise, I was able to define manufacturing tool, again, using the BFO terms function, realized, and process. And it looks like this. So a manufacturing tool is a material artifact which bears a function which is realized in manufacturing. Buildings are not tools, for instance. Clothing are not tools. Heating equipment probably is not a tool, unless you're using the heating equipment to heat is part of a manufacturing. Okay, so piece of equipment is similarly a hard problem. It's a material artifact used in an operation. An operation was also part of the 20-term list via operation specification, if I remember correctly. So we can't really define piece of equipment in any satisfactory sense, but we can define piece of manufacturing equipment using this same design pattern involving function, realization, and process. So a piece of manufacturing equipment is a piece of equipment that has a function which is such that any process which realizes that function is a manufacturing process. Now, I believe that this design pattern is very useful. And it was built into BFO from the very start. It's not something which we developed for the specific case of manufacturing. It's used everywhere where there are functions. All right, a manufacturing resource is a kind of independent continuant. So it could be a building, or it could be a brush to sweep up the metal, which has been the output of some lathe process. So that actually there is an error here. This should say continuant, not independent continuant. It could be a piece of software. And the key is that it should have a manufacturing resource role. And a piece of software has a manufacturing resource role if it's used in a manufacturing process. And the same goes for any other entity of manufacturing resource. Now, requirement is hello, yes? Yes, but unfortunately, it's not here. It's on the document that you have. So I selected those things which I thought I would need for the talk and put them in the slides. And clearly, I made a mistake here. So I should have included manufacturing resource role. But it is, there is a specification of what it means in the document. But basically, it's clear what it means. You have a manufacturing resource role when you are used, and we define use, or we specify the meaning of used in the document, used in a manufacturing process. To have a role of a manufacturing resource is to have the capability to serve as a manufacturing resource, which means that you're available one way or another. Now, requirement is a really difficult one, and this is connected with the question raised earlier about how we define the fact that some entity conforms to some specification. So similarly, we have a job defining how some entity conforms to a requirement. And Tom Hagedorn has produced some very nice work, BFO-based work, in the direction of a detailed account of this kind of entity. But for our present purposes, it's enough to say that a requirement prescribes some quality or process. And we remember discussion that prescribes from an earlier part. And then a design is a collection of product requirement specifications. This is, again, a very early statement. The important thing is that a design is a kind of directive information entity. You don't create designs for fun in the manufacturing world. You create designs because you want to change the world so that it includes entities that conform to your design. That's what directive information entity is. And then a feature. Now, I think this is just a grocery list. It can be anything. A feature can be a quality, a characteristic, a part. But a feature description is a descriptive information content entity. We can certainly say that. Transport process is pretty obvious. It's a planned process in which something is moved from one place to another. And all of that you can capture in BFO already, because we have the term site, which is the place where an entity is occupied. Quality specification is a kind of specification. This is relatively easy to define, but the term quality that we will need in the IOF includes more than what is included under the heading of quality in BFO, and I believe that the more that it includes can be captured by means of the term measured quality. So quality means something which conforms to a standard for which we have a measure which enables us to assess conformance to that standard. And that means that the entity in question is in the information artifact realm rather than in the real world quality realm. But again, that is something that has to be addressed by collaboration with experts. And then operation specification is a subclass of specification, which we document here. And a step is a subclass of action as defined in an operation specification. And a task is a subclass of process for which there is a task specification. And basically, it's an action or a complex of actions which is unified. And again, this is really just a test case, a demonstration that we can create a definition using BFO terms. It's not meant to be even the beginning of a final story. And that's the end.